Good morning, good afternoon, and good evening. I'd like to welcome all of you to Day 4 of Pivot 2020, kicking off the geothermal decade. I'm Kate Young, Geothermal Program Manager at the National Renewable Energy Laboratory in Colorado. NREL is a U.S. Department of Energy laboratory whose mission is to advance science and engineering to transform the way the world uses energy. NREL scientists work across the research lifecycle, from breakthroughs in fundamental science to integrated energy systems, through research grants from the US DOE, as well as through our more than 800 active partnerships with industry, universities, foundations, and governments around the world. Pivot 2020 is all about pivoting to geothermal, whether it's a shift in the renewable energy industry's paradigm from variable renewables to a flexible, always available renewable resource, or the oil and gas industry pivot of its capabilities and equipment to accessing heat. Today's session is drilling the wells of the
Kate, you got muted.
The session topic is all about another kind of shift, the shift from what geothermal wells look like today to what they may look like in the future to be able to access geothermal anywhere. We'll also talk about what it will take to get there. We have an exciting panel today made up of people both at the field level with the intimate knowledge of where we are today in the near term, as well as the executive level to highlight where they see the future of geothermal wells. If you have questions you'd like to ask the panelists, please get them in early. The best questions are those that are brief and address a specific panelist. We do have Rob Urselman on the phone today moderating the Q&As, and we'll take those in the second half of the session. So let's get to the introduction of our panelists. We have Christian George, VP of Wells and Deepwater and Surface Engineering Technologies from Royal Dutch Shell. Tony Pink, VP of Technology, Wellbore Technologies from National Oil Well Varco. Lance Cook, President of Sage Geothermal Systems and former Chief Scientist of Wells at Shell. Dr. Eric Van Oort, Professor of Petroleum Engineering. He also is the CEO of two startups, Evo Energy and Spider Automation from the University of Texas at Austin. We have Matthew Kelly, Well Engineer Manager with Mercury in New Zealand, also formerly with Halliburton as a geothermal driller there. And Iker Martinez, the senior completions engineer from Repsol. So all of you come from a place with varying levels of experience and interest in geothermal. And so I'm going to give you each a couple of minutes to introduce yourself and describe some of that interest and experience. So Iker, let's start with you.
Yes. Thank you very much. Good morning, good afternoon, good evening, everyone. My name is Iker Martinez. I'm a senior completions engineer at Repsol. I've been working for Repsol for the last 10 years, focused on completion, well testing, and well intervention engineering. And now I'm assigned at Repsol Technology Laboratories, which is one of the most cutting-edge private R&D models in Spain. So here in Repsol, we are visualizing the potential of low enthalpy power generation from our liability as an alternative of reducing OPEX, as a possible solution for platform electrification in brownfields in the North Sea, and as an alternative to delay our decommissioning costs, which are significant. We are though following up very closely what is going on Deep and EGS geothermal to understand whether or not this type of technology can suit in our strategy towards becoming a net zero company by 2050. So regarding drilling, I think oil and gas and geothermal drilling, they have a common objective. I mean, having more competitive drilling costs will imply having more competitive LCOEs, an improvement on ROPs, temperature rating of the tools, well stability and zonal isolation, or reducing the problems related with loss of circulation will play an important role on it. So, but I think we should not forget also about the continuous well integrity monitoring and building thorough corrosion erosion model to optimize the material selection. Thank you.
Okay, and next we'll go to Christian.
Hi there, Christian George. I'm spent my career in upstream, mostly in wells. Early part of my career I was in Schlumberger, but the last 25 years I've been working for Royal Dutch Shell. The roles I've had over the years have been sort of starting with drilling and completions, but over the last decade, really, I've specialized in performance, business performance and operational performance in wells. And the last few years, I've been in the technology side of things. You know, from my perspective, I guess from Shell perspective, we believe in more energy, but crucially cleaner energy in the future. And geothermal we see as a credible, competitive, low carbon option for the future. So I'm interested in how we get there. As much as the technology is going to help us, I believe the lessons of the past of business performance, of driving operational performance that we've learned in the oil and gas industry are very relevant here. So looking forward to some of that discussion today.
All right, thanks so much, Christian. Next we have Tony Pink.
Good morning, everyone. My name's Tony Pink, as Kate said, and my career has been in oil and gas for 30 years. Split between 17 years in Schlumberger, out in the field, drilling wells, both logging them and doing directional drilling. And the last 20 years has been trying to push the performance of those wells. And most recently has been sort of ventures into technology, where we were doing closed loop automation, taking data from downhole tools up through wired pipe into the rig's control system. And so it's really, you know, where I'm fascinated with geothermal is, and for NOV, is seeing, you know, how can we take all this drilling technology that we've got in the oil and gas and reposition that into the competitor to batteries. Yeah, you know, we want that that geothermal energy that's there at night and on calm days. And you know, we've got so much resources and horsepower available there in the oil and gas industry to help this industry. But I think the group we've got gathered here today on the phone are really there to hit some of the hard problems of how do we do this horizontally, or how do we do it very deep wells and drill through some very hard rock. Thanks.
Thank you, Tony. All right, next we have Lance.
Okay, my name's Lance Cook, and I graduated from Shell after 37 years as chief scientist and vice president of Wells Technologies. Back in the late 90s to 2005, we had a pretty big geothermal effort within Shell, and my partner and I, Dr. Lev Ring, developed a patent on something called the monodiameter well. And the idea was we were going to get down deep, you know, drill to the center of the earth or whatever with a 12¼ inch hole and be able to mine the heat. Well, in 2005, Shell got out of the geothermal as we had staff constraints and had to make some decisions. So here we are. I've graduated. Now I met Jamie Beard. So Jamie has this vision that she's going to get the best oil and gas mines, many of them here on the panel, to crack this nut. How are we going to get solar and wind type of performance in terms of cost so that geothermal is competitive? I'll tell you what I told Jamie. Well, I won't tell you. Just go check a post by John DeWart, back and forth between Jamie. What John DeWart's position is exactly what I got in an argument with Jamie about. And but Jamie in the end said, I told her, you know, how are you going to solve these problems? She said, I'm not going to solve them. That's your job. That's why I've contacted you. That's why you guys have to play this game. So so here I am, and my partner Lev Ring and I had sort of an epiphany, and we said, holy, you know, we actually think this is crackable. As John DeWart called it. He said it was a road to nirvana, but there's no path to get there. And my feeling is I can see a path. After we started thinking about it, after enough badgering from Jamie, we've created our own geothermal company to try to start a path to this geothermal nirvana. We'll talk a little bit about that and the sort of the technologies I think we need to do. Okay, that's it.
All right, thanks so much, Lance. Eric, you're up next.
Okay, good morning, everyone. My name is Eric van Oort, and there are a lot of people on this panel that have an association with Shell. So do I. I've worked for Shell for 20 years, and in 2012 I left Shell. I didn't retire from Shell. I left Shell to become a professor at UT Austin, where I specialize in drilling and completions. And what I do at Shell is I'm the director of two large consortia. One is called RAPID, the other one is called CODA. RAPID focuses on rig automation and performance improvement in drilling. So it deals with drilling automation, with novel sensors, with robotics and mechatronics, and to a large extent with data analytics and machine learning and artificial intelligence, which we will be able to leverage in the geothermal space as well. CODA focuses on the problem that Iker already mentioned, which is well abandonment and decommissioning is one of the biggest problems in oil and gas. Very high AROs for companies. It's going to be hundreds of billions of dollars spent in the next decades abandoning wells. So a big problem and a potential niche there for repurposing wells for geothermal. And Lance already mentioned Jamie Baird, who is our combined muse. All of this wouldn't have happened without Jamie. And Jamie got me excited and involved in the GEO organization at UT Austin, the Geothermal Entrepreneurial Organization, where I'm a co-PI, co-principal investigator. And I've started doing some work on deep closed loop geothermal systems, doing some really nice advanced modeling on multi-phase flow systems, still yet poorly funded, but hopefully that changes in the future. So I'm looking forward to talking more about that in this panel.
Thanks, Eric. And Matt, let's bring us home. Matt Kelly.
Hi. Yeah, thanks, Kate. Kia Katao, Selamat Pagi. Good morning, all. I'd like to thank you for including me in this panel, this distinguished panel, allowing me to participate in the conference. A little bit about myself. The first 30 of my career was spent in the 90s with Unocal Geothermal. Although it doesn't exist anymore, Unocal was a leader in the development of the geysers and Salton Sea fields in California and continued in the Philippines and Indonesia. So they're a big player in the industry, and they put on a lot of megawatts onto the world megawatt geothermal power production. And there's a lot of Unocal people still around the geothermal patch for sure. I started out in '91 providing engineering support for the surface facilities down in the Salton Sea, and then transferred into the drilling group and moved to Indonesia, where I spent the rest of the 90s drilling wells for Gunung Salak early units, a 380 megawatt power plant facility, and then helping to develop a hybrid rig solution for exploring Sarula in North Sumatra. I left Unocal to return home in the United States, where, among other pursuits, I continued to support geothermal power plants, both in facility and piping design work and a lot of more surface-related things, automation, not so much drilling. I was hired as a commissioning engineer in 2011, and then eventually became the general manager of Hudson Ranch Power Plant in the Salton Sea, the 60 megawatt power plant there. Then in 2004, I decided to return to Indonesia when an opportunity popped up with Halliburton, who had the IPM contract to drill 40 wells for the Sarula project. And that was those wells are now complete, and the Sarula project is online, 330 megawatts. And they're that was actually the largest single geothermal power plant development contract in the world, I think, ever. So it's pretty exciting to be involved with that. Right now, I'm helping in New Zealand, helping Mercury drill a few makeup wells to complete a workover campaign. So I definitely could be considered a practitioner of drilling geothermal wells, at least in the hydrothermal resource resources. That said, a couple of comments. First, other panelists in the prior sessions have mentioned that in past, geothermal is considered a niche market. That is still true now when compared to the scale of the oil and gas market, and that's probably why we're all here. I always felt that we were a bit of a step client to the rest of the service companies and the rig contractors because we just had no scale and we're a small market. Nowadays, I consider a large drilling campaign for a geothermal project anything more than 10 wells, maybe even 5 wells is a large campaign. And the 40 wells we drilled in Cerula is pretty much unheard of anymore.
So Matt, what's changed over these that you've been drilling geothermal wells with Unocal and Halliburton and now with Mercury? And what are the current problems with drilling these geothermal wells?
Yeah, so I'd have to say, you know, like I said, I started my career in drilling for about 10 years and I was out of drilling and I came back to the Cerula project drilling wells, and in that 15 to almost 20-year gap, there really wasn't a lot of change. The changes could be probably categorized in 3 main areas. Rig automation, if you can get a good newer rig automation has definitely gotten a lot better. The cyber-controlled rigs, automated pipe handling systems, automated catwalks that top drive the torque controls to help the drill bit and the drill string harmonics. The second category would probably using EMT or electromagnetic telemetry for steering the drill string for directional drilling. The third significant change that I saw over that time period was PDC bits have come quite a ways. Even in the last, we pushed the development of PDC bits at Cerula, and we also pushed it even and have used some here in New Zealand. And so those are getting much better, and we're able to get them to drill most of the formations we drill in, except for the harder ones, at least in the wells that I've drilled. What are the big problems? I'd say it could be categorized in 2 areas: poor drilling fluid circulation, and you know, and at least in a hydrothermal resource, the permeability you need for a good well precludes you from getting good returns while you're drilling that well. So if you drill a well with full returns to TD, that's an easy well, but it's probably not a very good well because of the flow rates you need and the permeability is so high. So that also causes problems with getting cuttings out of the hole. And one thing I still watched the panel on Rob's panel on the high-tech drilling techniques. And one of the things none of them really address is how to get their cuttings out of the hole. So that's a big problem for us. The other big problem I'd say is maybe completion design problems with the high temperature casing design that needs some improvement, especially in the big sizes we're talking about.
Okay. Thanks so much. So now we'll jump into our questions, and if I could ask panelists to keep your responses to about a minute, that helps keep the panel moving along a little bit. That would be great. So the next question we have is about fixing these problems. So Eric, you described yourself as a problem guy, the fixer, when you were with Shell. Are these problems that Matt's describing unique to geothermal? And can you describe similar situations in oil and gas? And has the petroleum industry been able to effectively deal with these issues? And if so, how? And after Eric, everyone else, please feel free to jump in with your own comments as well.
And you want all of this answered in 1 minute, Kate? Is that correct?
Feel free to go back and forth.
Well, yeah, let me jump in and reply to Matt. So drilling fluid issues, hole cleaning issues is an issue in oil and gas as well. There are some solutions to that. High pressure, high temperature fluid design is something that needs to be addressed, including high pressure, high temperature cement design. That is important. One thing that I've thought about a lot is loss circulation, the problem of loss circulation, which appears to be really bad in drilling geothermal wells. There, the oil and gas industry has found some really nice solutions that we really should try in the geothermal realm. And I'm talking first of all of managed pressure drilling techniques, pressurized mud cap drilling techniques. You can fix your hole cleaning problem by not cleaning your hole at all, right? Leaving everything downhole, doing pressurized mud cap drilling if you have formations that have large losses and in fracture systems. There is technology called artificial wellbore strengthening, which has been really successful in minimizing losses in plays with narrow drilling margins. Lance will undoubtedly be very familiar with the casing drilling and especially the solid expandable tubular and monobore technology that has been developed. If you do casing drilling, you get various benefits, one of them being casing smear, which is a way of drilling highly depleted formations and low circulation prone formations that mitigate low circulation. So to keep this short, but maybe we can explore some of the themes later on. There are some solutions within oil and gas that we should explore to address some of the problem areas in geothermal.
Thanks. Anyone else from the panel have a comment on ways oil and gas has been able to deal with these issues? Silence. All right. Christian, what about you? What was your experience? I know you mentioned that you worked sort of at arm's length with on the Habanero project in Australia. Do you have any comments on what your experience was working there?
Yeah, as you said, I wasn't directly involved. One of my team was seconded to Habanero when I was whilst I was working in Australia, and so I kind of followed it, albeit at slightly arm's length. There was a lot of challenges, and maybe I take it as sort of symptomatic of the challenges we need to face as a geothermal industry as we go forward. So what were those challenges? Slow, expensive drilling through hard rock. I think the project also discovered that hot doesn't necessarily mean dry. So they discovered high pressure water in mobile fractures and ended up with significant well control challenges associated with that project. I think the other part to it was, you could say that the operation was a success, but the patient died in that technically they achieved what they wanted to. They drilled the wells, they got a pilot plant that worked. It just didn't meet the economic hurdles that it needed to sort of be progressed further. And I think that kind of combination of the technical drilling challenges leading to a well that ultimately was successful, but just then was too expensive to make it a going concern is what we're about here. And the types of technologies that Eric was just talking about, managed pressure drilling, for example, I think is a really good opportunity for us to help reduce some of the challenges that they saw in Habanero and make more competitive wells in the future.
Thanks, Christian. And then Tony?
Yeah, I mean, I think, if we look at the geothermal challenges, yeah, and if we can answer a big fundamental question first is, can we expose enough rock by drilling down straight in a straight line vertically and get enough heat, or do we have to turn a corner and drill horizontally? Yeah. And the horizontal exposure of more rock in the oil and gas business, we now look back at it and think of it as super simple. But as I came into the industry, that was just as the horizontal wells were coming around. But our challenge, the two big challenges there is, which Christian supported, is we've got to break hard rock, and that efficiency still isn't there today. So do we have to look at some of the technologies out there on the edge, like plasma drilling and stuff that is a startup doing that? And then the other one is, can we turn the corner and drill directionally? Yeah, and to do that and to measure where we are and to transmit where we are, we've got to put some energy as an industry into plus 200 degrees C electronics. Yeah. And we are dabbling at a very light level in that with ourselves and NREL helping us. But our ability to get one little tiny chip that we might be able to measure vibration with is at least a year's work. Anyway, I'll let Lance chip in.
Okay, yeah. So I'll solve the hard rock problem for you real quick. Stay away from it.
Yeah.
Go sedimentary. So about 80% of the U.S. is covered by sedimentary rock, and so you can get temperature. The big issue is you've got to go deep, right? And so it's already been mentioned, monodiameter. The purpose of the monodiameter was to allow us, let me just describe my vision. What do we need? And we need it quick. We need distributed power. I want to be able to go drill a well to 20,000 feet. I want a 12¼ inch hole at bottom, and it all needs to be done at $10 million, right? We need the price target of $20 million to be competitive with wind and solar. We can do that. We're in, right? So basically what I need in my toolkit to do that is the monodiameter well. Or monobore. Weatherford calls it the monobore, and Venture calls it same drift or something like that. But they've been out there. They've been running some of these systems out there, some of the early versions of that. So that's there, and it probably needs to be refined a little bit. But suddenly you get rid of your ECD problems. That's a big problem when you're drilling deep. Is the ECD problems like Eric mentioned. And then I need managed pressure drilling with this 12¼ inch hole. If I can use managed pressure drilling close to balance, I can drill fast. I can drill really fast. I then need the PDC bits. PDC bits, hey, they're here. What I need is the soft torque, like from NOV, which takes the vibrations out of the string. Currently, when you drill deep, you're usually using 3½ or 2 7/8 inch drill pipe, and that is just too limber to actually work with these when you're at 20,000 feet with these soft torque programs. Think of it like you're jumping rope with kite string. It's just tough to do. You need a bigger rope. And when you go monodiameter 12¼ inch hole, you can drill with 5½ inch casing. And the system that we already have then becomes viable. And then what we've done is married up fracking down. So if you can then drill to 20,000 feet and then frack down to 20,500 feet or 25,000 feet to bring the hotter temperatures up. Now I know everybody in the audience, every frack engineer struggles to keep fracks from growing up. I will just tell you the secret. Real simple, take the current program you've got and use a frac fluid that has a higher density than the frac gradient, and you will frac down. And since we're not worried about permeability, we're worried about heat conductivity, you're not going to be worried about using weighting materials. So thanks.
Okay, thanks so much. All right, that leads us into our next question, which is, we've talked about what geothermal looks like today, vertical to subvertical wells that are drilled into existing reservoirs, natural fractures with fluid that is brought to the surface. So Lance, you gave us your vision. Others on the panel, what are your visions of what these future wells like? What are we going to be drilling in the next 5 to 10 years? And again, if I could remind you to keep your answers short so we can keep the discussion moving, that would be great. Yes, Eric.
Yeah, so as was already said by Matt and Tony, actually, we're pretty good at breaking hard rock, right? We've drilled stuff that's 20,000 PSI UCS and higher. PDC bits have come a long way, and there's some really exciting things that have happened with Chimera bits and hyperblade cutters and so on that I would kind of encourage people to look at. So we can break rock, as Lance said. What we need to control is the drill string dynamics. I don't think it's stick slip that we have to worry about. It's lateral vibrations deep down in hard rock that we need to control, but NOV and others are building the control systems for that. So we need what is known as closed loop drilling control. Has nothing to do with closed loop geothermal wells, but it's just a way of controlling the drill string. And then you need to drill directionally. And again, there some development is still necessary, but companies are doing fantastic things with respect to, for instance, the development of metal-to-metal motors, motors that can drill directionally without the use of seals, elastomer seals that are sensitive to temperature. So deep directional drilling, I think, is essential. I think we're going to see some fantastic development there. It will need to be supported, and that's a whole other discussion that we need to talk about, because companies are not going to develop this if this is just going to be a niche market, right? If there is no market for the products to be deployed. So I'll leave it at that right now, but I'm really excited about drilling technology, and we can talk about some new bits, new hole making technologies, and I'm not necessarily yet sold on plasma and laser drilling. I think there is some very exciting stuff that we can still do with rotary drilling.
Thanks, Eric. And Matt, on to you.
Yeah, so all these technologies are, I'm intimately familiar with all of them except maybe the monobore, and have tried some of them. We actually had a rig that had a closed loop soft torque system on it, drilling in this last campaign that we were dealing with, and it helped somewhat. The problem with all these technologies is we need some scale for someone to step out, and an operator is not going to drill, who's drilling 2 or 3 wells, maybe 5 wells, even 40 wells in Cerula. They didn't want to go too much out on a limb and try these new technologies. So what we need is either some sort of funding mechanism for the new technologies, or a volume of wells that you can get on that learning curve and have it pay out.
Thanks, Matt. Anyone else? Yes, Tony.
Yeah. So I think, supporting Matt, I mean, that's the trick, isn't it? Find a volume, So can we, design a heat field where on one location, we combine what Lance is doing, what Matt needs, what Eric said, which is, a well design with, they're directional, but not necessarily horizontal, but they, we build that sort of heat wells underneath, that's 100 wells, say, and they're spaced out enough that we're not sucking too much heat out of the rock, and then we get that scale. But I think some of the stuff we can do is with low tech and not high tech. Stability in the bottom hole assembly needs to be thought of. And roller reamers, seal bearing roller reamers are something that take away a lot of vibration, and we just need a beefed up design of that, because if we don't know where we're going, we want to try and guarantee that we're going in as straight a line as we possibly can, and then quickly run in a survey tool and confirm that we did drill in a straight line. So I think there's some low tech stuff we can do, and then I kind of disagree with Lance on the fracking down width, but maybe that's because I'm a rock mechanics guy originally. But I've over the years I've tried to keep an open mind on all this stuff, so I'm not going to poo-poo his idea. Cool.
All right, thanks so much. All right, so a lot of what we're talking about then is drilling deeper, drilling longer wells. Do we have what's needed to go cheaper? Do we need to innovate? So Christian, let's start with you. You were the former vice president for well performance. How did you make wells cheaper, and do you think we can use those things to make geothermal economic?
Yeah, I'd start with the comments that have just been made around scale. I think one of the things we've learned over the years, that repetition is the friend of the driller. If you do the same thing over and over again, you have a learning curve. You get to know the rock, and you get to know the equipment that you're using. How far can you push it? What's the sweet spot for its operation? But you also have the ability to develop a supply chain, providing materials to you at an ever lower cost. And I think the shales business, the unconventionals business in North America is just such a good example of how much cheaper, what an economy of scale and that learning curve can give us. We're now orders of magnitude lower in unit cost in those shale wells than we were just a decade ago. So that's the opportunity for us, and I completely agree. It's about economy of scale. And I think if you look at a lot of the projects we've had in the past in geothermal, they have been bespoke, and with bespoke comes additional cost, and that's what we need to step away from. I think, and I guess Kate, you and I had a bit of this conversation before, is that challenge between deep and cheap. And do we start a little shallower and be a bit dumber, but get the repetition and get the learning curve? Or do we go deeper and recognize the sort of value of that extra heat, but be prepared to spend more money on it? I'll stop there.
Thanks. And Tony, I'll go to you next.
Yeah. So yeah, I think again, somewhat supporting that. Maybe we do a 500 well campaign in an urban environment for tapping into heat for heating and not for geothermal power, and perfect some techniques from repetition there. And then I think it's finding the locations, if you combine a deep sedimentary basin with enough heat to drill a field profile where you don't have to move the rig very far, and we're drilling the same rock, and then gather as much data as we possibly can whilst doing it. And then, from being in the geothermal conferences, what really upset them was if the oil boys were being arrogant, about applying technology. So it seems to me that the right technology in the right place, yeah, and maybe it is surface automation. Maybe that's a relatively low cost thing that does repetition and does it in a quick and fast way without having to put expensive downhole tools and expensive techniques in the wellbore. Cool.
And then Eric, when you and I talked, you mentioned some additional efficiency measures and drilling limiters. Can you talk more about that?
Yeah, I'm going to talk about that. I'm going to give Christian some grief as well, because and I can do that because I used to work for Shell as well. So indeed, what has happened in unconventionals is tremendous optimization through what is known as technical limiter redesign, really taking wells and taking them apart, looking at ways to drill faster and better, and taking out non-productive time and invisible lost time. We've been very effective in this. What operators have also done, and here is where I'm going to give Christian some grief, because it might be a blocker for geothermal technology development, is they've really squeezed the supply chain and really driven costs down to bare bones, while at the same time kind of pushing a lot of the R&D and technology development to the vendors, right? And when that technology then gets applied, like soft torque, right, for stick slip mitigation, then it's the operator that benefits from it, right? And there's still very few business models where there is a true win-win between operators and contractors. And if that's going to happen again in the geothermal space, that's just going to hamper technology development. I see it right now as a blocker for the further development and adoption of automation, because the vendors really don't get rewarded for their investment. So a new business model is really necessary that really incentivizes the rig suppliers and the OEMs. I'll leave it at that.
Thanks, Eric. So Lance, when we talked about your new company, Sage Geosystems, you had a different perspective. You talked about using 1970s, 1980s technology to get to where you need to go. Can you elaborate more on that?
I just think we can get there quickly. There's a lot of new technologies that have been mentioned that we'll ultimately want and need. But if you steer towards sedimentary rocks, then I think that life becomes a lot easier. And I'll just say something that Eric mentioned early on. If we really want to jumpstart this thing, is retrofit old wells. So if we can figure out how to retrofit old wells that are a huge abandonment liability for the oil and gas business, we will get oil and gas interested in this very quickly.
Thanks so much, Lance. And Ika, when you and I talked, you also had some ideas for what's needed and what needs to be improved. Do you want to have the final comment on this question?
Yeah, thank you. Yeah, I think one of the main factors to be considered is warranting the well integrity of the well. I mean, if you see the cost not only of the drilling, the cost of the entire life of the well. In wells where you are drilling through fracture formations, one of the problems that you might have is that in the case in cementing operation, your top of cement, you can find it way lower than planned. So that could be a problem in the future, which at the end is going to probably need of remedial jobs. So I think monitoring the well integrity throughout the well lifetime is very important. In fact, Repsol is developing together with Advanced Energy Consortium and Tubal Energy a system which allows to see what is going on behind the casing, mainly pressure and temperature conditions, and have this reading real time at surface. So I think that is quite a good technology to bear in mind for geothermal wells.
Okay, thanks so much, Igor. We've got one more question that we'll go through with our panelists before we get to the Q&As from the audience, so please keep those questions coming. I see we've got a lot of them coming in already. So the last question that many of you guys had thoughts on was, how do you think we're going to get there as an industry? What do you think is needed? What will it take? What's going to really drive this change and drive this pivot that we've been talking about? Tony, do you want to start?
Yeah, I guess the big one is some cash. Yeah, I think there's been a lot of frustration, probably corporately, governmentally, angel investment, private equity. None of that has really looked at geothermal, and with the scale of the opportunity there to do that, you know, I really think you know, we create an organization or canvas the government or multi-governments to an investment in the, you know, $250 million, $500 million range, where we can pick a big project, create a big project, and do something to make those giant changes occur. Yeah, this little dibble dabbling in it has slowed the geothermal industry down and kept it in the niche markets in Iceland and New Zealand and California. And really, we want to exploit that energy that's there underneath the whole planet and do that. But I think we need a scale up on financing of a substantive size. Yeah.
And you think if that happens, it's possible?
I think so. Yeah, absolutely. Yeah. Hell, we can get to the moon. So why can't we drill a deep hole in the ground? Seems crazy.
All right. Okay, Matt, I see your hand up. We'll go to you next.
You know, just a quick one. Like you said, cash is king, and we need somehow for private companies to be able to make money, or public companies for that matter. Governments can't be funding the whole thing. And that said, it needs to be economic somehow. So I'm a little bit of a skeptic on these low temperature and sedimentary basins ideas, but maybe it'll be the answer.
All right, thanks. Lance, how about you next?
Yeah, it was mentioned yesterday on yesterday's panel of creating a consortium of the industry of geothermal, oil and gas, whoever will play, to actually solve some of these problems together. Work on the fundamentals and share the information. So just wanted to mention that.
Thanks. And Eric?
Yeah, I concur with the previous speakers, right? First of all, somebody needs to step up as the integrator, right? Integrating all the bits and pieces, because there's good stuff going on with individual companies, but nobody's really integrating this in an integrated solution that ultimately gets geothermal wells of the future drilled. And then right now, you cannot approach NOV, you cannot go to Halliburton, Schlumberger, Baker, Weatherford, and ask them to invest in technology development at the current state of the oil and gas industry. That's not going to happen. So you need to come up with funding from other sources, government sources, the Gates Foundation, other philanthropy, bring in a big pool of money. And then you go to NOV and ask them to develop metal motors and new bits and new telemetry, right? And I think that would work. And this is kind of starting what Jamie calls this Manhattan project of geothermal. It would be fantastic if that could materialize, but it does require the right amount of funding and the right amount of integration as well. Somebody needs to step up and integrate.
And what about the roles of the military or startups or other industries like vehicles and aviation? Do those also play a role in advancing this?
Well, the Department of the Defense, the DoD, could be a big accelerator in this, right? That was discussed on previous panels. That would be fantastic if they would show an interest, because it would mean energy dependence of their bases around the world if you would drill geothermal wells there. So they could be an important accelerator. I think everybody has a role to play. All the startups have a role to play there as well. But again, just a startup working on an individual drilling technology, right? Interesting as it might be, is not going to provide the full solution, right? Of casing, cement, directional drilling technology, what have you, right? So you still need somebody to pull all of that together and make sure that funding goes out to startups such that they have the leeway to further develop their technology.
Thanks, Eric. We'll go to Christian and then Iker.
Yeah, I agree with all that's been said. I'm maybe a glass half full kind of guy, but I do see that there is an opportunity right now. We are in the midst of a transition as an industry, as we all know. There is appetite for lower carbon solutions for the future, not just from the kind of existing industry bodies, but from the types of philanthropic bodies that Eric was just talking about. I think there is an opportunity right now to seize the enthusiasm and the search for those lower carbon energy sources, that we can start to find more funding and a momentum for us as a geothermal industry. So I'm positive that we take advantage of what's available right now. I also think we need, there's two bits we need to prove up. That we need to prove some of the technological ambition we have, that the startups are offering, but we also need to prove the commercial realization, the lower unit of energy. And I think that's the kind of hurdle we need to challenge ourselves in this next couple of years. How do we get over that? How do we demonstrate not just technical but commercial success, so that we can get the economy of scale we were talking about earlier?
Thanks, Christian. And then Iker.
Well, I think there is not much I can add here. I think, as I said before, I think it is very important to find some innovative solutions for improving the efficiency of binary cycles or any other type of technology of energy harvesting. But what I think it is important is that the geothermal industry have to convince multi-energy companies or oil and gas companies that there is potential for generating power, and there is potential of drilling cheaper these geothermal wells, so that they can commit with a bigger scale project and get some income from that.
Thanks, Iker. So now let's turn to some questions for our panel. And the first one comes from BP. It says, how can we avoid polluting new geothermal drilling projects with some of the bad habits and legacy process of conventional drilling? For example, slow technology adoption, limited sensing capabilities, ego-based decision-making. Tony, looks like you're anxious to talk.
I want to back Eric up on that. I think we have to have a totally different business model on this, where the technology partners and the team providing those services share in the rewards of what they do by driving the performance up. So if the performance, what's happened in oil and gas is performance going up and up and up and up, and effectively revenue to the service companies and the drilling contractors has gone down and down and down to the point where we are now, which is the drillers and a lot of smaller service companies are going to go bust in the next 6 months. Yeah, so that that efficiency has that we've created has hurt us. Yeah, so there is a business model that can be created where we all share in this. So why not start in the right place in geothermal to do this? Yeah.
Thanks, Tony. Christian?
Just a real quick one. So I agree with both Eric and Tony on this. I think we do need a new model. What I would say is, if you look around the oil and gas industry, historically, the approach that we've taken in North America, that is, sort of evolved that market economy of very much the lowest bidder wins the contract, is not symptomatic of the way we approach things globally. There's some brilliant examples around the world, certainly over my career, where we have had a much more joined up approach as a team that's developing something, and we all share in the risk and the reward. So I take the challenge, but I think there's models out there that we can lean on that have worked well in the past and would set us up well for the future for geothermal.
Okay, we'll take Lance and then Tony and then Eric.
So I think the model will naturally change, because as soon as you go into geothermal, you're going into PPA agreements where you're contracted to deliver X amount. You're not in this whipsaw environment of oil and gas where you're drilling to produce oil when the price is 100, and then you're dropping rigs otherwise. You get these long-term contracts, and then you get to fulfill them. So that's it.
All right, Tony.
Yeah, it was only a quick comment to back up. You know, we actually really had some collaborative agreements in the North Sea in the 90s. Yeah. You know, drilling the limit, and then what BP and the others were doing on Magnus and Witch Farm. You know, Witch Farm was an amazing case of how we drilled these 37,000-foot wells, and you never knew on that rig site who worked for BP and who didn't. Yeah, it was just one team. Yeah, so we can do it. We just lost it somewhere along the way. Yeah.
Thanks, Eric.
Yeah, so in addition to these new collaborative agreements, which I strongly support, we need to get away from siloing of the disciplines, right? Treating the disciplines as separately and having separate KPIs for each discipline, right? Drillers being focused on drilling the well fast, and petrophysicists caring all about getting their data and so on, right? It needs to have much more multidisciplinary interaction. Drilling success will depend heavily on geology and petrophysics. Operation of the well will depend heavily on geophysics, right? So there needs to be alignment, multidisciplinary collaboration across the disciplines with a shared KPI data set, a shared set of metrics that everybody gets aligned on. And oil and gas, I hate to say it, is not yet there in this. There is still very much siloing of the disciplines, each one's with their own separate KPIs, their separate indicators of what they're trying to achieve. And that has, I think, hampered getting holistically to the best end result, right?
Thanks. All right, our next question comes from Scott Petrie for Matt. There are some good hardware solutions out there to reduce temperature of bottom hole assemblies, like continuous circulation that has been used in Cerula and some of the air and foam drilling done in PNG, which are applicable to lost circulation. What is stopping operators from using technologies like these?
That's interesting, because I brought that circulation package onto the Cerula project and then brought it over to another project on Java. And I was looking at bringing it over to New Zealand. Continuous circulation is something that will help keep the tools cool as we're drilling. I've routinely drilled in formations, static formation temperatures greater than 300 degrees. You know, the last 3 wells I just drilled here in New Zealand were higher than 300 degrees. And we do it just by cooling our way down the hole. And we're not using high temperature. I mean, we're using relatively high temperature tools, but we keep everything under 100 degrees C in the drill string, and we're able to drill to 3,000 meters or so. So, you know, it is possible to use high temperature tools, and the continuous circulation is a good tool, and I'm a proponent for it.
So Matt, can you tell me how much water you've been pumping down these wells, or what the rate is, and do you think that's feasible throughout the world, or is it unique to?
Well, that is a big issue. Most of the places I drill, there's lots of water around. I'm either in the jungles in Indonesia or here in New Zealand. You know, we're pumping almost 1,400 GPM when we're drilling blind and 12¼ inch hole. So 1,400 gallons a minute is you know, what, 40 or so barrels a minute.
Thanks.
It's quite high rates.
Thanks, Eric, and then Tony.
Yeah, I just want to show the audience how much of a science nerd I am, but I want to caution people about cooling in particular, because, and this is where you need this integration of the disciplines, right? You go and drill these wells, talk to some geomechanics experts, because if you cool down the well, you actually reduce the near wellbore hoop stress, and induced fracturing and reopening of fracturing becomes a lot easier. So you create worse slurse circulation problems. So it's a self-inflicted wound that happens on all high pressure, high temperature wells, where people are cooling and using mud coolers to cool down their fluids to keep their telemetry working downhole, and actually are creating huge loss circulation problems for themselves. So that's something to consider, right? There's a solution to that. You can talk to me about that if you're interested in it also after the panel. But do understand that if you do one thing, there could be a chain reaction and some unintended knock-on effects, and especially with cooling, that's the case.
Yeah, we just figure you were drilling and stimulating at the same time.
Yes, indeed. Indeed.
Unfortunately, it falls apart lots of times.
Yeah, but I think you know, again, it's you know, the amount of great ideas coming out this panel alone, you know, is very interesting, and the interdependencies, you know, between them. But you know, again, you know, we are capable now of getting power downhole. So if you can get power downhole, rather than building, you know, high temperature electronics, which is a place we're going, can you refrigerate the electronics by using the power that you've got down there? So, you know, there's an alternative way of doing it, that if the chipset is tiny and we can get that data up and we've got power and data down the hole, then, you know, we don't need those high temperature electronics, because we refrigerate, we mount the electronics on Peltier plates and then cool the plate. So it becomes a non-issue then, yeah. So, yeah.
All right, so on to our next question. Do you see the opportunity to construct these wells cementless, especially if high temperature cement is problematic? And so I guess I'd like to start with Lance.
I think it is doable. So there's been some expansion into the formation work that has been done where you get away from cement. So I think it is doable. And I'll just leave it at that. You can check out some of the papers and all that have been written on that.
All right, Christian.
Just a quick one. I think there's an overlap here with the work that's ongoing with two other sort of challenges that we have as an industry. One is the abandonment work, and how do we develop sealing techniques for disposing of old wells. And the second is carbon capture, and the work that's ongoing to develop effective cements and isolations for wells that ultimately will have to stand a very long time of sealing. So I think there's some technology advances that we can piggyback on here that might help geothermal too.
Okay, and Eric, I figured you'd have some input as well, huh?
Yeah. I mean, it gets to my favorite topic, which is kind of dissing Portland cement. Right, Portland cement is just not a good zonal isolation material. I'm sorry. It's brittle. When it cracks, it doesn't reheal. I can understand why people started to use it, but we need to get away from it. So we need indeed alternative sealing solutions, alternative sealing materials. And as Christian said, there's a lot of exciting things happening there right now in the well abandonment space, looking at alternative materials, but it's not going to be Portland. It has to be something else. And there are good candidates right now. There's quite a bit of literature being generated on good solutions.
Okay, thanks. And this next question, this is a topic that's come up on previous panels as well. And this is a question for the whole panel. It says, am I missing the consortiums that are testing these technologies systematically? There seems to be a great need to test some of these ideas, similar to what was done in the Bakken early on, to understand the best methods. A consortia could maximize the dollars we have to a few heavily researched tests. So does anyone want to take that one first? All right, Lance, I'll go to you.
I agree. We need it.
Yeah, Tony. Oh, you're on mute, Tony.
Yeah, to get that change in momentum. Yeah, I think it is. You know, we talked about getting a change in momentum, getting a large sum of money. You know, starting off with a decent business plan. Then it sounds like a consortia as wide as possible would be really good. And Christian triggered a sort of thought in my mind. I think it was Christian, that because of this stability and a non-cyclical nature of the revenue that would come in post-thing, that I think some of that danger goes away, you know, if you have that shared group, yeah. So if we can do it in an economic way, but the prize is 50 years worth of revenue, then that whole planning thing for that consortia is much more stable, yeah.
All right, the next question comes in, and it says, if drillers encounter an oil reservoir on the way to deep granitic basins for the geothermal energy, would they stop there and start production from an oil reservoir? And I guess I would also flip that and say, if you guys have oil and gas wells that are in good condition and currently operational, do you see them as being reusable? Can you use them to drill deeper? And I guess, Lance, I'd like to start with you on this one. I know that you have some ideas on this.
If you don't have the lease, you can't produce the oil. So if you've got the lease, then you've got the option to stop and produce the oil. And I could very well see when you're drilling wells, you always have a geologic bailout, right? So your main reservoir isn't there. You have a secondary target. And it would be fantastic if we could get it to where heat is the bailout, right? So the well goes down, you've got $6 million into it, and the thing's a dry hole. If we could then convert that, start designing wells where you can have geothermal as a bailout, that would be fantastic. And then this issue about retrofitting, going back in these hundreds of thousands of wells that need to be plug and abandoned. If we can figure out how to convert those, I think that'll just really jumpstart the whole geothermal bandwagon.
And Eric, what do you think about the reuse of oil and gas wells for geothermal? Do you think, with all the millions of wells we have, that's a feasible future, at least in the near term?
I think it's a fascinating thing that should be explored, right? And I think it's a compelling reason why oil and gas companies should be interested in it, because they have such large AROs, and most of the companies haven't probably budgeted for what essentially is a non-return on investment, right? This abandonment and decommissioning of these, what are actually millions of wells around the world. I'm going to say something that I said also on Tuesday in the deep closed loop or closed loop session, is that we need to be a bit careful, and this goes back to something that Iker said already as well. Iker said, pardon me, which is we need to look at well integrity, and we need to see if the well can handle kind of the load cases with its new life as a geothermal well, right? We put wells, as well engineers, we put wells together for specific purposes. Exploration wells are not put together like production wells, right? There are differences between them. So we need to see if we have in the integrity and the ability to carry the production loads. And if we even have the bore size, right? As Lance said, you'd like to get at least bigger than 8.5, preferably 12.25 inch. That's not probably not going to happen if you have a South Texas well where your last string was 5 inch or so, right? You would probably be better off drilling a whole new well rather than repurposing an old well. So definitely should look at it. It's a compelling proposition, but make sure that you do your homework.
All right, this next question, yes, let's take a comment from Tony, and then Eric.
Yeah, very quick. There was a tiny little political undertone to that question, and what I've heard is from some of the renewable energy people a desire to not have the oil and gas industry engaged. Yeah, and I think that's crazy. Yeah. I think what you really want is you want to turn this, no pun intended, turn the supertanker around and get that energy that has been in there in the oil and gas business, providing energy to our planet for its use, to repurpose that where appropriate into geothermal. And I think that is a trend that should occur and needs to occur, not hindered in any way, shape or form. Yeah.
Thanks, Tony. All right, Eric, this question has come in for you. You were talking about integration. So how do you visualize the integration that's required? on the side of the traditional oil field service companies or in the side of the newcomers as large oil and gas operators jumping now in the renewables business? Or is it the side of some industry consortium?
Yeah, I think this idea of a large industry consortium is really compelling. A consortium that can pool funding from various sources. We talked about government sources, we talked about philanthropy. We have talked to various oil and gas companies and they're very interested. They haven't made the leap into significant investment yet, although some companies have supported startups and quite well. Ultimately, you need to bring all of that together, right, in a joint industry consortium with an advisory board and a technical board that disperses the funding to the various parties that are going to develop the technologies, and that have an ultimate goal in mind of having a prospect where you want to drill some wells and demonstrate some technologies. I think that can be done. It will require a coalition of the willing. What is definitely going to stand in the way of that is people are becoming very proprietary and very tight to the vest with respect to IP. So I hope that doesn't happen. I hope that there's more of a willingness to share and move forward collaboratively in first of all defining the gaps and needs that we need in terms of technology, then going about a very structured, well-funded way in developing it and testing it out in the field, and that is what the integration requires.
Okay, our next question, and Tony, I'll direct this one at you. Can you speak to geothermal directional drilling capabilities today? In my experience with unconventional oil and gas development, the directional tools utilized have a temperature ceiling in the range of 350 degrees Fahrenheit.
So the person who asked the question is pretty well spot on, yeah. And every degree above that, the reliability is going to go down and down and down. But that doesn't mean that we can't attack it from two fronts, which is the one we're doing with NREL, which is, you know, what components can we get in the system that get up to the 400 degrees C mark? So do that. What components can we mount on power provided refrigeration and do that? And what telemetry methodology can we use to get away from having mechanical pulsing technology or EMAG that requires electrical windings and things? So we have to think about it totally differently. The other one is think completely differently and think about, you know, new PDC design, shape cutters and a fluid hammer. Can you make enough noise whilst drilling the section and a percussion methodology to drill fast that could be triangulated at the surface, so you have less need to understand where you are whilst drilling? So there are ways of thinking out the box that, you know, that dead end that we have at the moment on 350 F or F electronics. I think we need to find a way around that dead end so that we can do directional control at high temperature. Yeah.
Thanks, Tony. And so now we've got just about 5 minutes left, so I'll give you each 30 seconds or so to give a closing comment, and then I'll close the panel up. So Iker, I'll start with you, and then we'll go to Matt.
Okay, thanks very much, Kate. So now it's very good to see that all the effort is being done for geothermal energy. So I hope to see improvements on drilling cost and facilities efficiency so that investor can make robust numbers to take decision to invest in geothermal. So I like also to congratulate organizers and moderators of this event for the excellent job being done and for the diffusion that this event is having. And I do encourage to all attendees to keep working hard to push geothermal energy to become the energy of this decade.
Thanks, Iker. Matt and then Christian.
Yeah, just a couple of things. I have yet to be convinced that conductive heat transfer, which all these lower temperature designs and repurposing of oil wells rely on, conductive heat transfer will work economically, where it's hard enough where convective heat transfer, which is what hydrothermal resources, classic geothermal, is profitable. The other thing is the concept we're all operating in some of these small little boxes trying to you know, to maximize our own little bit. That consortium idea is intriguing to me, to try and get a little bit more momentum in a group effort kind of idea. That's it.
Thanks, Christian, and then Lance.
Yeah, so I've just been mulling on the conversation around a consortia. I think that's an excellent way forward. I also just kind of add into that this reflection that I truly believe the learnings and the capability from the oil and gas industry have to play here. We have to carry the learnings over, and the competency and experience that exists in the industry. It's a perfect match. But there's another bit, which is this is also an opportunity to bring in innovation, new thinking from other industries. So if we are forming a consortia, it's a great opportunity to kind of create that collective in a way maybe that we haven't had in the oil and gas industry. But thanks for inviting me to the panel today. Really enjoyed it.
Thanks, Lance, and then Tony.
I think the key is going to be we're going to have to crack the nut on costs. Like Igor said, we're going to have to be competitive with wind and solar, and the sooner we can show that there's a path to do that, the better. The consortia is probably the way to fast track that. And then I'll just say, oil and gas. I mean, oil and gas wants to be green. I'm not sure what oil and gas brings to the table when you talk about wind, solar, nuclear, hydro. There's just not the expertise in E&P companies to actually contribute much there. If you want to play, if oil and gas is going to really go green, I think they really need to take a hard look at geothermal.
Thanks, Lance. Tony, and then we'll wrap up with Eric.
Yeah, I think this panel and the you know differing backgrounds of the panelists in this from oil and gas, and that desire, I think the consortia is the resonant word that's come out of this panel. I think I've got faith out of this last hour and a half that we can do something like this together, and stop and listen to Matt and the guys in geothermal, take their lessons learned, blend them with the oil and gas lessons learned, and go out there and do something. Yeah, I think it's quite exciting times actually.
Thanks, Tony. And Eric?
Yeah, I want to end with a message to young people, to young scientists. I hope that if you've been watching this, you've been seeing that this is an exciting area with lots of technology challenges, lots of great R&D and technology development that still needs to happen. So it's an area worthy of your time and attention, and maybe dedicating a career to. We need to get it better funded, and we need to get organized, and the people that you see on the call need to make that happen. But if we then do that, then it's a very interesting area to get involved with. It's high tech, it's sexy. This is where you need to look. So don't just look at going to work for Tesla and SpaceX and Amazon. Go work for geothermal.
Thanks so much. And just thank you to all of your panelists. I've had such an exciting time talking with you this past week and today during the panel. Thank you to the audience for all of your questions and for joining us today. I want to give a shout out to Malcolm Ross and to Rob Ursulman, who are behind the scenes producing this session. We will send out any of the questions that we haven't gotten a chance to get to today. We'll send out to the panelists and give them an opportunity to answer them. So please check back on the website, and please feel free to reach out to any of the panelists, connect with us on LinkedIn, and continue the conversation. The next Pivot 2020 session starts in 30 minutes at 11:45 Central Time in the US, titled Geothermal Prospecting, Thermal and Hydrothermal Exploration. So we hope you join us. Thanks so much and have a safe and happy rest of your day.